Hello, my name is Lawrence, and this is my capstone project. So for the project itself, I wanted to learn more about 3D modeling and 3D printing. I've already had some experience with both of these because I've taken engineering and drafting at school, but I felt that I wanted to learn more about it and go more in depth. So for the past year that I've been 3D printing, I've tried to tackle some of my personal projects, so such as a cup stabilizer, an RC car, and maybe a laptop stand. So as you can see here, I've built the RC car, and but to explain to you how I did it, I've summarized it into 4 stages, which I've labeled the process. So first of all, stage 1, learning how to use Fusion 360. So the reason why I'm trying to learn how to use Fusion 360 was because Mr. Neeson, our teacher, introduced it to me at the end of grade 11, and he made us do a couple of assignments, which included this assignment here, which is a ring clamp. But it is also because I've noticed a large number of YouTubers using Fusion 360, leading me to believe that Fusion 360 was one of the better modeling softwares out there. This was also handy when I needed to look for YouTube tutorials to help with the learning process. Secondly, getting my own 3D printer, assembling it, and learning how to use its controls. And finally, familiarizing myself with the functions of Cura because Cura was a slicing software I had previously used and had experience with, and it was the only software I could download for free. Before randomly buying my own 3D printer, I wanted to do a lot more online research first, and I went through a lot of websites and YouTube videos trying to figure out which printer was the best. And what I came across was that almost all 3D printing enthusiasts claimed that the Creality Ender 3 Pro was the best printer for its price, not only because it was on the cheaper side of the spectrum, but it also possessed remarkable print quality which could be compared to $1,000 printers. So after buying it, all that was left to do was to build it. So when I opened the box, I noticed that a lot of the parts were already put together, but there were some parts that I had to assemble myself, which included the extruder, which you can see here, and also the power outlet too. And this was a video of me before I put the Ender 3 Pro together and had the parts all laid out. So you can see there was an instruction manual and some tools for me to put the product together. And finally, in all its majesty, this was the final product. So now we can move on to stage 2, which was designing the object. But before we can even start modeling the object on Fusion 360, we first have to create sketches of the object with measurements, which is basically our blueprint. And the reason why we do this is because it'll give me a general idea of what the object will look like, and it will give me time to design and produce measurements to work around the parameters of the project. And these are some of the sketches that I created for my projects, such as the cup stabilizer, the RC car, and also some parts within the RC car, such as the servo and also the cover. After we have completed the sketches, we can now move on to the 3D modeling step in the process. Right now, I have the Fusion 360 page open and loaded the assembly view of the first project I started with, the laptop stand. So this is a general overview of the laptop stand that I created. Um, as you can see, the laptop sits on top of these 3 areas, and the stopper at the very front stops the laptop from sliding down. And you can take a look at the design that I chose for this laptop stand. It's more of a U-shaped, and the reason why I did this was because it allowed me to print this entire section as one piece instead of having to print multiple pieces. And this one piece design made the laptop stand really, really strong. And also you can take a look at the constraints here that I used to put all these pieces together. And as I said before, since Fusion 360 was very similar to Inventor, so using the constraints wasn't very hard for me. Instead, it was kind of like a refresher. Moving on from the laptop stand, now we can go into the other project that I made, which was the cup stabilizer. So the cup stabilizer was actually a project that I did for my grandmother because she would always walk up the stairs with a hot cup of tea, and I didn't want the hot tea to kind of spill over and burn her, so I created this design. So first step to creating this was making the cup that my grandmother usually uses. So the cup itself wasn't that hard, except the handle was a little tricky. But there was a sweet kind of function that allowed me to do this was the sweep command. So what I did for the sweep command was create a line that outlined the handle, and I created a profile to sweep along that line, and which created the kind of shape you see on the screen. So let's take a look at the assembly view. So this is a general overview of what the cup stabilizer looks like. So the cup sits in the very middle, and on top here I put a string through it so my grandmother can hold on to it. And this cup stabilizer uses centripetal force to kind of make sure that the content inside the cup stays in place so it doesn't spill out. So even though the physics behind the cup stabilizer is pretty straightforward, printing it was a totally different story. Because the handle of my cup stabilizer exceeded the 45-degree angle limit, I had to make the cup stabilizer into two pieces and then print it separately. And this was the area that I was concerned about because my printer cannot print a layer of plastic on thin air. So I separated into the top section and the bottom section. So for the top section, I was able to print it on its side so I can get a nice foundation. And for the bottom section, I was able to print it upright because a lot of the angles didn't exceed that 45-degree limit. And you can see here I made a hole through the two pieces so I can put a pin through it so I can secure the two pieces together with a mechanical connection instead of using a connection relying on friction. Now we can move on to my other project, which is the main project that I did, was the RC car. So let's click into the RC car folder and take a look at the parts. So these are all the parts that I created, and for the RC car, it was probably one of my more complex projects because there's so many moving parts that needed to be put together. So I'll open the assembly view and let's take a look at that. So this is this general overview of what the RC car looks like, or the frame. So that's the top view. Let's take a look at side view. So we focus our attention on the front of the car. So I'll take off the lid, and then inside you can see that there was a servo, which I previously mentioned. The reason why I created the servo is because I needed to use it as a reference point. And you can see the servo kind of controls the axes on the side, so it kind of can steer the car around. And now if we focus our attention in the middle of the car, you can see that I left a giant hole. And the reason why I did this is because that's where the battery pack will go. And I left a hole there so I can easily access the battery pack from underneath the car, so I don't need to keep taking the battery pack out of the frame. Now we can look at the back part of the RC car. So as you can see, I made a motor there which can slide, and also these gear slots can also slide too. It's because it's really hard to kind of measure the placement for these gears. So instead of putting a fixed point, I made it so I can slide so I can easily adjust the positioning of the gears later on. And you may have realized that I didn't actually make my own gears. The reason being was that my 3D printer was unable to print the teeth precisely. Instead, the teeth of the gears started to merge together as the print went on. And there you have it. Now you have a general understanding of how the RC car works. We can now finally move on to stage 3, which is converting the STL file to G-codes using the slicing software Cura. However, I also want to talk about 3D printing the object, which is stage 4, simultaneously because of the cause and effect of these two stages. In order to make a G-code, we first have to prepare a 3D model in Fusion by converting it into an STL file. To do so, we first have to select the file and select 3D print. Then now we can select the object that we want to 3D print. When I select the object, you might notice that there are a lot of triangles that make up the object. This is because the computer uses an array of triangles to form the curved parts on the object. As you can see, there's 6,000 or so triangles. So we're going to select medium and we're going to press OK. Now we can just name it axis and we'll save it onto our desktop. Now if we move on to Cura, so this is the home page for Cura. We're going to slide that over and put in our STL file. So now our STL file is on the build plate. So as you can see, our axis is now laying flush onto the build plate, and now we can slice it. Using Cura is relatively easy for complete beginners because they've simplified the slicing process to only the few features you see here, such as profile and infill, and the more complex features are hidden away. But you can easily access the more hidden and complex functions by clicking the button Custom, which will lead you to the custom commands. Here, you're given a variety of different options to change. However, in our case, I want to direct your attention to the speed, which is the printing speed. So we can select that and open it up. Because our object has such a small profile on the bottom, we need to change something that's called the initial layer speed, and it controls how fast the initial layer is printed. This drastically helps with ensuring that the adhesion between the first layer and the bed of the printer is leveled. Now, aside from adjusting the speed of the printer, we can also try using supports and build plate adhesion methods to help with the quality of the print. For supports, it is auto-generated by the computer if we choose to use them. We can also find supports back in the recommended section and we can select them there. On the other hand, you have more variety with the build plate adhesion because there are multiple selections that you can make, such as skirt or raft. In this case, we will use raft because of the small profile on the bottom of our print. However, when I first used raft, it melted on my print. To avoid this problem, I found that if I add an air gap between my raft and my print, it will create some separation between the two. With that said, we can now finally slice our object by selecting the Slice button. But before we print it, we can also take a look at a preview of our object by selecting the Preview button. This will give us an overview of what the printed object looks like, as you can see here. Also, as I said before, since our object has such a small profile on the bottom, we added the wrap to give it a better surface to adhere to. And if you look carefully, you can see the air gap between the two. I'll zoom in a little closer so you can have a better look, and you have to look very carefully. Now, to further examine our 3D print, Cura also has another cool feature that allows you to see the print layer by layer. As you can see here, I can remove the layers and add layers. And this kind of gives you a preview of how the printer prints layer by layer. Once I'm satisfied with the print, I'll take a look at how much time it takes. In this case, it'll take 42 minutes, and then I'll save to file. Here I have it labeled CE30 Pro Access, and it's now going to be finally converted into a G-code, and it will be later transferred onto my 3D printer using an SD card. After 42 minutes of printing, this is the final result. Now all that's left to do is build the RC car. Now, the final test drive. With that, my capstone comes to an end, but my passion for designing will continue on as I pursue my dreams to become an engineer. Through these series of personal projects that I tackled, I discovered that there's so much more that I've yet to learn and experience. In hindsight, there's so many different improvements I could have made for the RC car, such as adding suspension, decreasing the weight, improving the motor, and the gear ratio. The reason I love 3D modeling is because it is an endless pursuit of knowledge and that there's very few limitations to how you can create a design. This experience has really taught me to keep an open mind to new ideas and become a problem solver when things don't go as planned. When I look back at this project, not only will I remember what I've created, but also the many things I have learned.